Hi, everybody. Welcome to the video on chapter 1. Chapter 1 is a little bit, is just an introduction to chemistry. It's challenging. I don't know how much chemistry everybody in the class has had to this point. So we're just going to start off slow, and hopefully if you have had some chemistry, this will be easier to follow. So we're going to start out just talking about what is chemistry. So chemistry is defined as the study of matter. And so some of the things that you need to know about matter, some people say study of matter and its transformations. Some of the things you might need to know is exactly what is matter. We're going to come into that in chapter 2. We're going to talk in great detail about what matter is. But if we're looking at how do we study it, we're going to study a variety of things about matter. We're going to study its composition. What's it made up of? What's inside of it? We're going to measure it or study its structure. Structure is talking about how those pieces that are inside are connected. So a lot of people think composition and structure are the same, but they're not. So for example, there are compounds that have the composition C2H6O. That's its composition. Each unit is built up of 2 carbons, 6 hydrogens, and an oxygen. However, I can write different structures for that. I can write a structure that looks like this, and this compound is called ethanol, or I could write a structure that looks like this. Now we're going to, in chapter 6, draw these structures, and so if they don't really make too much sense to you right now, don't be too alarmed. And this one is called dimethyl ether. So those are different structures with the same composition. So we study both of those aspects. And then we also study the properties of matter. When we study the properties of matter, there are 2 different types. We study physical and we study chemical. The difference between physical and chemical properties we'll go over in several different chapters, but I'm just going to give you the basic information on it now. If something is physical, what's true is the identity of the substance does not change. So you could change its temperature, you could change its size, you could change its density. But if you have water, H2O, and you have ice, H2O, that you freeze or melt it, that's a physical change. The temperature at which it boils or melts, those are physical properties because it's always going to be water, whether it's liquid or solid. Chemical, though, actually changes the identity. So for example, if you mix baking soda and vinegar together and you see bubbles, those bubbles that come out are carbon dioxide gas, and carbon dioxide gas is not present in baking soda or vinegar, and so you created a new substance, you changed the identity. That would be a chemical process. So we'll come back as we go through the chapters and talk a little bit more about those. So the other thing I wanted to talk about in this chapter is how we study chemistry. And the traditional way that people look at to study science is the scientific method. Now, the scientific method typically has a couple of different steps. You start out with an observation. And so an observation is just you observe something and you're curious about it and you want to know more about it. It could be a quantitative or a qualitative observation. We're going to come back to that in the second half of the chapter. Once you have an observation and you see what's going on, you would then formulate a hypothesis. Hypothesis is some kind of testable process to explore the observation. Or in another way, it's a idea or an assumption to explain what's going on. It's a possible explanation, but it has to be testable. After you have a hypothesis and you make your explanation and your testable process, what you would do is actually do the experiment. This is a controlled test. And that controlled test is going to be testing your hypothesis. After you do your experiment, you're going to get some results. Now, those results will either support the hypothesis, right? You're going to get results, and from the results you would conclude that they support the hypothesis or that it does not. If it does not support the hypothesis, you would go back up to this step again. If you do a whole bunch of experiments on your hypothesis and your hypothesis has many tests that support it, you end up with many tests supporting your hypothesis can turn into two different things. It will either become a theory, which is a supported explanation. Usually theories are comprehensive, big ideas that cover a wide variety of things, or you could have created a law. A scientific law is simply a pattern of behavior. And typically, they are mathematical in nature. When we get into chapter 2 and we start talking about states of matters, I'll show you the difference between a theory and a law in a little bit more detail. Now, this is the process that people have put in place and is taught all throughout elementary school, middle school. And so there's some pieces of this that are problematic. One thing is, if I make an observation, the very next step I do is not typically find a hypothesis. What I normally would do is to research, see what other people know about that. The other piece of this is, after you have your information, what you need to do is communicate it, so that they know what it is, so when they're doing research on the same thing, you don't duplicate work. So some people have added these pieces into the scientific method, and others have stuck with the basic. Some people have completely changed the idea, and instead of thinking about the scientific method, what they like to talk about is a wheel of inquiry. And if you go to Canvas, I put some examples of inquiry wheels for you. But the inquiry wheel, let me just show you one for a second. I'm going to stop sharing the whiteboard and go to a different screen. If you look at the inquiry wheel, you'll see that it's more circular. And so it shows that the steps can really be done in any direction. So you're going to start again with an observation, but from the observation, you could define your problem, form a question, investigate what's known. You can communicate at any time. So the spokes are trying to represent that you can go in any order you want. It doesn't have to follow a specific pattern. And other people have tried to show it in other ways. So I gave you a couple examples, and you can take a look at those. Okay, so back to our method. So you could look at the scientific inquiry wheel and see if that makes a little bit more sense to you. The last bit I want to talk about in this particular video clip is the difference between technology and science. Technology and science are really very, very close together. Science is a little bit more basic or broad. So science is really anything trying to make sense of the natural world. Investigating the natural world. Now, the natural world could be anything, including things on Earth, things in outer space. But really, you're just trying to figure out, are there patterns, or what's organized out there, what things exist. Technology is a little bit more specific. Technology is that you're going to take or apply scientific knowledge for a specific purpose. So science is very broad and really has no ultimate goal other than to understand things. Technology is more specific. It wants to actually use that knowledge to do things. And so along with that, when people are studying, there's two different types of research that you can then talk about. Research can be basic, or research could be applied. And typically basic research is associated with science and applied research is associated with technology, although there is some crossover. Now, the difference in the types of research might not seem that important, but in the history of looking at science, especially in the United States, is that historically most research was funded by government and some by corporations. And so when the funding was from governments, we did a lot of research on basic, looking just how do things exist, what are they, what's out there. However, the funding streams have changed, and whereas it used to probably be 90% government funding and 10% corporate funding, at this point it's probably about 80% corporate funding and 20% government funding, and that has switched the focus to technology and applied research. And so there are some benefits of that, and of course some detriments to that. And so it's just something to think about, that the things that are being studied are not always just because they're interesting or out there, but they are chosen because they will benefit corporations. This is especially true when it comes to things like medical research. If you think about how much money has been put into things like Propecia for hair loss or Viagra for male dysfunction, compared to the amount of money that's put into rare genetic diseases that only affect a small number of people, the proportion of money going into out of the total research budget is a little bit skewed. There's more money in the products that are going to be easily profitable at the end versus putting money into research that will probably only help a few people and not have a lot of customers to buy the final product. So research over time has been skewed from mostly basic to now mostly applied, and that does have ramifications. So that's all I'm going to talk about in this particular video. There'll be a part 2 for chapter 1 where we're going to talk about measurements and get a little bit of mathematics built into it.